புரியுது. மைலேஜ் சார் இங்க ஒரு
Sir,
So right now the next heading is Kepler's law of planetary motion. Kepler's laws of planetary motion. There are basically three laws that are associated with how the planets are going to revolve around the sun. As the name suggests, right? Kepler's law of planetary motion means how are the planets going to revolve? Is what the question is, right? So there are basically three laws that are associated, which was proposed by a scientist named Kepler, right? So first point is so the first law is called as the law of orbits or the first law, right? So the statement for this law goes like this. Each planet revolves around the sun in not a circular orbit, rather in an elliptical orbit. Okay? In an elliptical orbit with a sun situated at one of the telescopes. Okay? I need to explain this. So what is happening? So here, the planets are there, right? They are going to revolve around the sun, right? Where the sun is placed at one of the foci of a shape of a two-dimensional shape called as ellipse. So if I take a shape like this, which is an oval shape, where it has two axes associated with it, which is called as the major axis and the minor axis, on which you have 2 points called as the foci. So singular is called focus, plural is called foci, or some people call it as foci or both are right? So at one of the focus, if the sun is situated and the planet is revolving, then we call this kind of a motion as elliptical motion. And that is what Kepler's first law speaks about. What does it say? Each planet revolves around the sun in an elliptical orbit where the sun is situated at one of the focus. Right? Next is, if I take this axis PA, right, it is basically a circle which is pressed on top. So if I take a circle, it is going to be a perfect shape, right? This is a circle. So if I take this circle, so if I take the circle and press it on the top, what will happen? one side we get elongated, the other side we get compressed. So that shape is what is an ellipse. So about ellipse, you learn it under conic sections in your mathematics. Okay. In your conic sections, you have circles, parabola. Parabola we have already seen where it is. Projectile motion. Then you have ellipse. Then you have something called as hyperbola. Okay. So about hyperbola, we'll be seeing it in thermodynamics. So this is what an ellipse is. Have this point in your mind. For ellipse, there are two axes. What are they? One is called as major axis, and the second is called as minor axis. Which one is major axis? The axis that is passing through the bigger curvature. So the axis of the bigger curvature is what is called as the major axis, and the axis of the smaller curvature is what is called as the minor axis. And major axis is generally represented with the value 2a. And minor axis is represented with the value 2b. Are you able to understand? So it is represented as 2a and 2b, where if you take the center to be the origin, then you can divide it into two small major segments and two smaller minor segments. So this is a semi-major axis. This is a semi-major segment. This is a semi-minor segment, and this is a semi-minor segment. Right? So if you look at the points, there are 2 points that we have taken, right? One is P, right? So P is a point which is closest to the sun, and A is a point which is farthest from the sun. Okay. So if you see the proof of Kepler's first law of planetary motion, right? So it is basically proved on the concept of, or using the concept of, 1 minute, wait, I have to. So what is that? N vector is equal to GMS into MP divided by R. So what is this thing? Vector form of gravitational force, right? So the planetary motion takes place under the influence of what? See, whenever a planet has to revolve, there needs to be some force which is making that object revolve in the curvature. Or else what would have happened? It would have flown away something, right? So if the curvature has to be maintained, there needs to be some gravitation, there needs to be some force. So in this case, it's the gravitational force which is responsible for the planet to revolve around the sun. And what is the value of the gravitational force that comes out as? It is going to be capital G into ms. What does ms stand for? It is the mass of the sun. Into mp stands for the mass of the, what is it? So mp stands for the mass of the planet divided by, it is not r3, it is r cube. It is r cube times r vector. So I told you in the vector form itself, when we use r square in the denominator, when we use r square in the denominator, when you write it as r cap, when you write this as r cap, you use r square. When you write it as r vector, you use r cube, right? I've already shown the sequence. Last class I explained. That was the first class. Check your first ones. The vector is equal to G m1 m2 divided by r square into r cap, right? So this will be equal to G m1 m divided by r square into r cap is r vector divided by r no. So r square into r is going to be r cube. So that is why when you write it as r vector, you write it as r cube in the denominator. When you write it as r cap, you write it as r square in the denominator. This is a very important concept. Next year, the first chapter itself will start with this kind of a concept. R vector and R cap, electrostatics. Okay. So here I want you to take an important. So what are the steps that are involved in the proof? The first thing is for the planet to revolve around the sun, you need a gravitational force, and its value is given as GMS into MV divided by R cube times R vector. Right. The next question is, since it is revolving in a curved path, what about the torque experienced by it? So when you calculate the torque experienced by it, right, what is the expression, what is the vector form of torque? Torque vector is equal to R vector cross F vector. Right. So it is going to be R vector cross G ms into MP divided by R cube into R vector. So cross product of the vector with itself is always a zero. So answer will be zero. So here it clearly mentions that the torque experienced by this planet above the sun is going to be zero. So when torque is going to be zero, you can say that the angular momentum is, the rate of change of angular momentum is zero. Why is it so? Because torque is equal to dl by dt. I told you, right? How will you remember it? Force is equal to, when you write about force is dp by dt. What about torque? dl by dt. So when torque is zero, dl by dt is zero. So what is dl by dt? Rate of change of angular momentum is zero. So when rate of change of something is zero, then something is always a constant. So here, what is a constant? Angular momentum is a constant. This is a very, very important point. So when the planets are revolving in this elliptical orbit, the first conclusion that we can draw is that the angular momentum of the planet at any point on the path is always a constant. Is this point getting registered? And because this is effective, this is R vector. That's right. And that's why we have an equation. Actually, here also you need to have a minus. Because forces, the planet is being attracted towards the sun. But R vector is away from the sun. So they both are in opposite direction. That is why there is a minus. Actually, we need the minus here. Okay. Is this point here? So I want everybody to note this point that the angular momentum of the planet about the sun remains constant, both in terms of magnitude and direction. Is this point getting registered? Right. So have this in your mind. Based on this, we will see the next law. Right? Shall we? I'm very good. Based on this, we'll see the next law. That is called as the law of areas. It's called as the law of areas. It's called the second law. Okay. The second law of Kepler is also called as law of areas. So it states something like this. The radius vector drawn from the sun to the planet, right? If from the sun to the planet, if you draw a radius vector, and let's say the planet is revolving in the anti-clockwise direction. when I say the planets are revolving in the anti-clockwise direction, then read the statement. The radius vector sweeps out equal areas in equal intervals of time. Means in time delta t, let me take two areas. One is I'm saying that the planet has swept between A to B in time delta t. In some other region, it has swept from C to D. Right. So you're able to see a particular region swept by it. Right. So this area. This is one area, this is another area. Now what they're trying to say is, if the planet has traveled from A to B in time delta t or C to D in the same time delta t, okay, then the radial vector has covered an area, then the magnitude of these two areas will be the same. Is that point clear? Is it clear? So when the planet goes from A to D or C to D in the same time delta t, so A to B is a separate instant, C to D is a separate instant. We are able to see a shaded region. There is an area here, there is an area here. The magnitude of these two areas will be the same. Is that point clear? So if this area is A1, I take this to be A2. A1 is equal to A2. Now read the statement and you will understand. The radius vector drawn from the sun to the planet sweeps out equal areas in equal intervals of time. That is the meaning. So that's what they've given in the explanation. Read and see. Suppose a planet takes some same time to go from position A to B, as in going from C to D, then from Kepler's second law, the areas ASP and areas CST covered must be equal. Okay. There is another way to state this also. When area covered in equal intervals of time is the same, you can also see that dA by dt is a constant. What is dA by dt? It's called areal velocity. It's called areal velocity. Right. Now let us see the proof of Kepler's second law of planetary motion. Right. Again, the same logic. Consider a planet moving in an elliptical orbit with the sun at one of the foci. Let R vector be the position vector of the planet with respect to sun, and F is the gravitational force acting on the particle. Then what did we prove in the previous case? That the torque experienced by the planet is a zero, due to which angular momentum was observed to be constant. So since angular momentum is constant, right? Now based on that, we are going to now see whenever you have any kind of a curvature, right? You have any kind of a curvature. For that curvature, you can measure the velocity at that point by drawing a tangent at that. Now what will you do? You draw a tangent, and the tangent will be the direction of motion of the object. Here, if the planet is revolving in anti-clockwise direction, I'm drawing a tangent here and drawing a tangent here. Right? Now, what is happening? Suppose the planet moves from position P to P dash in time delta t. The area swept by the radius vector is given by the area of this small triangle that you have considered. So what they have done is they have taken a very small distance, so that this curvature is there, it is ignored and it is treated like a triangle itself. Right? So the area swept by the radius vector R is given by the area of the triangular region S, P and P dash. Is this point getting registered? Means this curvature is taken to be a straight line. Now the question is, what is the area of a triangle in terms of vector? It is half into A vector cross B vector. Okay. So here what will happen, half into R vector cross P dash vector. Because this is also R vector, this is also R vector. Right? So half into R vector cross P dash vector. Now for this P dash, what I'm going to do is I'm going to find that value using the triangle of vectors. So though the magnitude of this R vector and this R vector are same, what is different? The orientations are different, right? They're different, they're in different directions, right? So what I can do is if I take the triangle, so if I take the triangle S P dash, then what can I say? R vector or R1 vector. Let me call this as R1 for instance. So SP I'm calling it as R1. So R1 vector plus delta R. Right. So can I take it as SP vector plus P dash vector is equal to SP dash vector. So if I call SP vector as R1 vector plus what is P dash vector, that is what we are interested to find. Is equal to, if I call this as R2 vector, then what is P dash vector equal to? R2 vector minus R1 vector, which you can consolidate and call it as delta R. So that is why you see P dash vector is directly taken as delta R vector. Because it's a difference in two values. It is delta R vector. Right? Now, what is P vector equal to? This velocity is there, right? P vector is equal to, can I write it as delta R vector divided by delta T? Can I? So what is delta R vector? P vector into delta T. See guys, you can copy it from the left hand side, but I'm writing the reasons on the right hand side. So I'm explaining this there. I hope you're able to understand. I'm explaining this particular step. But in the place of V vector, what can I write? Can I write it as P vector divided by M? Why? Because linear momentum is equal to mass into velocity. So velocity is linear momentum divided by mass into delta T. Now what I'll do is, in the place of P dash vector, I will substitute P vector by M into delta T. When I do that. Right, when we do that, what are we going to get? Delta A vector will be equal to half into R vector cross P vector by M into delta T. I take the delta T to the other side. Then what will happen? Delta A vector divided by delta T is equal to 1 divided by 2M because that's a scalar quantity. So 1 divided by 2M into R vector cross P vector comes. So what is R vector cross P vector? It is angular momentum, right? So L vector divided by 2M, where M is the mass of the planet. Am I clear to this point? Now comes the question. Going back to the beginning, what is L vector? It's a constant. What about the mass of the planet? It's a constant. So when you divide both, it will be a constant. That is why delta A vector divided by delta T is considered to be a constant. Correct? And the last law. Right? Next. The next point is about the law of periods. That is the third law. It speaks about the time period. Because when a particle is revolving in any closed curved path, it's going to have a time period associated with it. So it states like this. The square, right now, the square of the period of revolution, or you can make it as the square of the time period of revolution. The square of the time period of revolution of a planet around the sun. The square of the period of revolution of a planet around the sun is proportional to the cube of the semi-major axis of its elliptical orbit. It's proportional to the cube of the semi-major axis of its elliptical orbit. So it states like this: if capital T is taken as the period of revolution of the planet, and if R is taken to be the length of the semi-major axis of the elliptical orbit, then according to the statement, D square is directly proportional to cube of R. D square is directly proportional to R cube. Am I clear with this? Right? So when you remove the proportionality symbol, you need to introduce a constant. When you introduce a constant, the scale that is introduced, which is just a proportionality constant. It has not much importance here, because we don't discuss about it. It's clear. So when you take the ratio, it will be like this: T1 square divided by T2 square is equal to R1 cube divided by R1 cube. T1 square by T2 square is equal to R1 cube divided by R2 cube. This clearly indicates that larger is the distance of the planet from the sun, what is going to happen? Obviously, the time period of revolution is going to be more. So that is when you see the period of revolution of Pluto, it is 247 years. It takes 247 years to complete one revolution, whereas for Mercury it takes only 81 days. Is the point clear? Will I proceed? Hmm? So the proof is, suppose a planet of mass and moves around the sun. See, what we have done here is, for us to take the forces into consideration, we need to consider this to be a circular planet. Okay. So suppose a planet of mass moves around the sun in a circular orbit of radius r. So let's say it is revolving with an orbital speed of value v. If m is the mass of the sun, then the force of gravitation between the sun and the planet will be the one which is necessary to provide the centripetal force. So G capital M into small m divided by r square would be equal to, I'll take it as r. Okay, r square is equal to m into v square divided by r. R and r will get cancelled, m and n will get cancelled. So what can you see? V square will be equal to G into capital M divided by r square. Sorry, r. Capital M divided by r. Now, our job is to find the time period. So, time period can write it as circumference divided by speed. So, circumference is 2 by r divided by speed is going to be root of gm divided by r. So, t will be equal to 2 pi divided by root of gm into r power 3 by 2. Because this r is there, here it is root r will go to the numerator, r into root r is going to be r power 3 by 2. Square on both the sides, what will you get? Which implies t square is equal to 4 pi square by g square m square into r cube. So d square is equal to 4 pi square by g square m square into r cube, and t square is directly proportional to r cube. That is what Kepler's third law speaks. So if we saw that k times r cube, right? The value of k, if you substitute this 4 pi square g square m square, you're going to get the value as 2.97 into 10 power minus 19 second square per meter cube. 2.97 into 10 power minus 19 second square per meter cube. Four pi square by gm into r cube. So this is all about Kepler's law. With this, we are done with gravitation. Wait, it's a very small second. We'll solve some problems based on. Shall I proceed? So the formula that we are going to use are one thing, angular momentum, how is it given as? It is m into v into r. So whenever you talk about a planetary motion, what is constant? Angular momentum is constant or torque is V. So this can be an MCQ question. Right? Next is law of areas. So what are the law of areas speak about? The radial vectors will speak out equal areas in equal intervals of time, or you say that the areal velocity is always a constant. Third, law of periods. So law of periods is T square is directly proportional to RP, but T is the time period and R is the length of the semi-major axis. Okay, and most of the time we'll be using this comparative basis only. T2 square by T1 square is equal to R2 cube by R1 cube. Okay, so based on this, let's look at the first problem. Tell me how to solve this. Calculate the period of revolution. Right. Calculate the period of revolution of Neptune around the sun. Given that the diameter of it is, sorry, its orbit is 30 times the diameter of Earth's orbit around the sun. Both orbits are being assumed to be circular. So they are saying you assume both the orbits to be circular. Okay. Calculate the period of revolution of Neptune around the sun. Given that the diameter of its orbit is 30 times diameter of Earth. So how to proceed? Simple. What do we know? T square is directly proportional to R cube. So when this proportional to R cube, can I say diameter cube also? Because I'll put 2R the whole cube, 2R the whole cube. It's going to be the same. Right? So which implies T2 square by T1 square is equal to R2 cube by R1 cube. So T2 square is what I need to find. T2 square divided by what is the time period of Earth? $365 days, it is going to complete. 365 square is equal to what is R2 cube? 30 Earth. It's no need. Because the 2 will get cancelled in 30 cube divided by. So actually it is 30R divided by. So find out what is the answer and tell me. calculation but is there any doubt? Sure. Previous slide is this thing. No? T1 square by T2 square will be R1 cube by R2. Then I will do this. Okay. Is the point clear? So any other doubt? After this, I wanted to discuss the previous two papers. I went through your papers. Total disappointment. Except one paper. Total disappointment. Like what? Right. That is she came into the- We would work on anything. The test. You didn't write the second test. Work on anything. You didn't upload it. You wrote. You didn't write. But if you guys actually go and work out and see, my concern is not about the marks. Did you at least bother to go and re-verify your mistakes? At least do you know what are the mistakes? 4 point, I remember solving so many problems like this. Right? Where after each subtopic, I was solving at least 7 to 8 problems. In spite of it, if that is going to be this, what is the point? I think it's like theorem with the at least problems I can understand. Theorem with the right? Yeah, what is happening as I can solve. Because the biggest problem is not the previous book, it's the one which is coming on Saturday. What chapter is that? Now, what did I tell you before I started that chapter? It's a nightmare for many people. Prepare for I worked on so many problems. In spite of it, you have 1 week of taking classes when you're not revising. Are you guys using the study material that is given, or is it in somewhere in the rack? Are you using it? If you use it, you will not have this issue. I don't want to discuss the answers in public forum. I've written the comments there. But I'm at least wondering if you guys know what is the mistake. Any mistakes பண்ண தெரியுமா? Even bother. எவ்வளவு வரும் நினைச்சு? Out of 35, what is your expectation? Approximate number. Idea. உனக்கு 15 above. You can try to. Any idea? This is bothering me. This attitude is bothering me. And repeating it again for the marks is not important at all. If you're not able to score, we are here only to help you, that we can do it. first not taking the test seriously. Why are we supposed to call you and tell that come and write the test? Why are we supposed to call you? Is it our responsibility, your studying, or yes? Isn't it your responsibility to chase us to ask when can I come and write the test if I miss? Am I right or right? Second, if you have written the test, not even one person has reached out asking for the solutions. Did you guys ask? Did you guys go and check whether the solutions are uploaded in the app? How are you going to correct yourself? This is for 6th chapter. How many chapters are there? 15, huh? Nothing is deleted for your information. Nothing is deleted. And this is where the first thing will start saying that physics is tough. It's not only about from my side, you guys have to work in parallel. Physics is tough only. I'll tell you again, 11th is comparatively tougher than 12th. Telling this also. This tough only. But a little bit of effort is what I'm expecting. I'm not expecting marks at all, but this attitude is not going to take you anywhere. You still are in the mindset of 10th standard. Last minute mark. I'll be very honest and rude outside my mind. There is a chance you will not even clear the paper. Do you want to put yourself in that kind of scenario? I have the control of not saying your marks outside. What if those marks in a class of yours, front of 40 or 45 students, is told in front of everyone? Will you be able to take them? Will you be able to? Then there are two options. One is shameless, we'll laugh and say that day also got only this much, I also. That is one useless comparison. You want to be there, you can be there, I don't mind. Or you want to be an example or inspiration for others, then you should work. You want to be a wrong example and take other useless wrong examples, or you want to be better compared to others. What is your choice? You want to be a good example or you want to be a wrong example? Comparison or somebody should say that okay, I'll be the last person to speak about marks. Okay, telling you that was not a person. I'll be the last person to speak. But my point is only one thing: the attitude of not being bothered about yourself is bothering. There is no point in me holding PDMs. And nothing is going to work unless you guys are going. Unless no formality. I can only say that they will do in confidence. Until you guys are going to work, I can do nothing. Right? You need to put in effort, right? See, tomorrow I'm not interested to take class. Okay, first of all, you would have seen me, I'm so dull also, I'm down also. It's not because I'm not well or something, because of the score that I saw. Corrected today was so down. That is not what I thought, and that is not what has put me down. I'm not going to teach tomorrow. Is the point clear? I'm not in a hurry to complete the portions also. Even if I skip 2 chapters, I don't mind. 0 on the 10 mark point, I'll skip 2 chapters also, I don't mind. Don't worry. But point is, I'm not in a hurry to complete the portions unless you guys are working in parallel. Day after tomorrow's test is going to be, I'll not say it is tough, but that chapter needs a lot of hard work. Today, after going home, you are going to sit and work on that chapter completely. Is the point clear? The study material is there. Go through every point, write down the definitions, prepare short notes. I want everybody to send me personal. Is it clear? And a short notes clear definition, torque and the definition, mathematical expression. What is the SI unit? Is it a scalar quantity or vector quantity? Otherwise, those kind of mistakes are also there. To do that, it is an insult to me. There is no point in me spending time on people like that. I have to see like that. I want to generate the best out of it. I don't mind. Even if you know zero, I don't mind. You are both on a physics spelling unless you are showing me that improvement of you working hard, I'm not going to put in effort. I need to see that you have a drive for yourself. You're gonna waste. I'm struggling with 12th standard and all. I can't take this. It hit my health also. When you people are not serious about your health. I don't have any necessity. Absolutely speaking. Breathe. Night you guys are trying to sit and work and take down short notes. Record work you're not sleeping, don't sleep. I don't mind. That's your headache. Or you better manage your time properly. Don't come and tell me I didn't have time. Tomorrow's class I'm cancelling. The whole day you have time. 4:30 on an average, every school gets over. 4:30 to 10:30 would open buddy. Day after tomorrow, I want to see everybody coming here and writing the test. Don't sit at home and chill. I want you all to see it. And if you have any other classes or something, I want the test to be written on Monday. Monday, is the point clear? Now the test is like I need to judge younger again because that is the end of mechanics. That's the volume. I cannot teach. Formula get a 3 year. You get a 3 year. In a tomorrow you will forget. I'll write and give. The subjects are interrelated. Better forget your marks. Clear? So after this is over, I wanted to ensure that wanted to discuss the paper. Is there any question that you have a doubt with? Who knows if you remember at this? So what is the answer for the first one? There is a raindrop of 0.2 gram falling with uniform velocity of 25 centimeters per second. What is the weight of it? Answer. Okay. What is weight? Oh, sorry. You're right. Had it been in horizontal motion, that would have been right? Last of that. So 0.02 Newton, correct? Energy is there. But had the object moved in horizontal direction with a uniform velocity, the answer would have been 0. Second, 3 blocks of masses 2, 3, and 5 kilograms are connected with each other with right sticks and are then placed on smooth frictionless surface. The surface is pulled with a force F from the side of the lighter mass so that it moves with an acceleration of 1 meter per second square. T1 and T2 are the tension will see the value of T2 is. So acceleration is given. Can you tell me the value of T1 directly? Or can you tell me the value of T2 directly? Looking at the answer, option you can see. So this tension T2 is responsible to pull how many blocks? You can directly do it. T2 is pulling how many blocks? This side is the force acting. How many blocks is it pulling? 1. What is that 1 block? 5. That 5 kilogram block is going with what acceleration? 1. So 5 into 1 is That's the answer. Clear? You need not sit and draw the free body diagram and solve it. Though you need to do it. This one. Adjoining figure shows a mass of 6 kilograms suspended by rope of length 2 meter. Okay, there is a rope of length 2 meter. A force of 50 Newton is applied in the horizontal direction at the midpoint. What is the angle of the rope makes with the vertical equilibrium? So there is a tension acting here. Right? This tension can be resolved into two components, T cos theta and T sin theta. So T cos theta is balanced by 60 Newton. And T sin theta is balanced by 50 Newton. Upper tan theta never 5 by 6 theta is tan inverse of 5 by 6. This is all. Purida. Newton's second law is applied to a rigid body. When acceleration of the center of mass. The maximum force of static friction up to which a body does not move is called as. It's called limiting friction. What is the normal reaction? Normal reaction is basically a perpendicular force. Normal stands for perpendicular. So it's a perpendicular force which is acting. Perpendicular force to whom? To the surface of contact. Right. So you can write it in your own words also. The booklet definition you need not memorize. Break the word and see. It's a reaction. And it is in which direction? Normal. Normal, it is perpendicular. So it's a perpendicular reaction to, you need to answer, is it a contact force or a non-contact force? It's a contact force. So perpendicular force to the surface of contact is what is called as normal reaction, right? There is a car of mass 1000 kilograms which is going with velocity of 10 meters per second. It's acted upon by force of 1000 Newton due to an engine and retarding force of 500 Newton due to friction. What is the velocity in 10 seconds? So initial velocity is 10 meters per second. Funny cut. Do it fast. 2 minutes time. That's right. So U is how much? 10 meters per second. Correct? What is the acceleration? So U is 10 meters per second. Acceleration is 500 divided by 1000. This is half. Why is it 500 by 1000? Because 1000 is positive force, 500 is negative force. Subtract both. So 500 divided by 1000 is going to be half meters per second square. And time is how much? 10 seconds. So V is equal to U plus 18. So V is equal to 10 plus half into T is going to be 10. So it is going to be 15 meters per second. Correct. State Newton's second law. F is equal to ma. State Newton's second law of motion. The external force is directly proportional to the rate of change of linear momentum. If you write F is equal to M, it is not right. You have to write the applied external force is directly proportional to the rate of change of linear momentum. So tell me these two. 5 2 and 6 2 Newton are acting on a body of mass 1000 kg at an angle of 60 degrees with each other. Find the acceleration distance covered and the velocity of the mass after 10 seconds. So forces of how much? 5 2 and 6 2 are acting at an angle of 60 degrees to each other. Find the acceleration distance and the velocity of the mass after 10 seconds. Everyone. So first find the resultant. How will you find the resultant? Root of f1 square plus f2 square plus 2f1 f2 cos 60 here. So root of f1 square over 50 here. f2 square over 72 plus 2 into f1 into f2 over. So 6 into 5 30, 30 into 2 is 60, 60 into 2 is 120 into cos 60 is half. It is going to be 60. So that is going to be root 110 plus 72. That is root 182. So it is root 182 Newton. Do prime factorization, write it in the form of square root. 182 you can do. So how much is it? I think it's working now. So it's a composite number. What are the two prime numbers we are getting? 291. 91 can basically become 13 into 7. It will not working. 27 31. Okay. So root 182 Newton. So root 182 there. So since you know the score, let's say this is the direction in which the force is acting. So what will you write? F is equal to ma, which implies root 182 is equal to mass 1000 into a. So it is root 182 divided by 1000, which is the acceleration. Correct? What about the distance? Root 182 is 13.49. Okay, root 182 is 13.49. Acceleration is 13.49 by 1000. Okay, correct. So what about the velocity? So since they didn't mention anything about the initial velocity, it can be taken to be zero. The object started moving only after the application of force, obviously. So U is 0 means V is equal to U plus 8 here. V and our V is equal to A into T. A root 182 divided by 1000 into time is 10 seconds. It cancelled. You get the answer. So 13.49 is what is root 182. So root 182 13.49. So 13.49 by 1000. On the acceleration. So 13.49 by 100 is how much? 0.018. What you told is right. One 349 meters per second. Distance calculated on a S is equal to half 80 square. So 13.49 is 13.49 by 2 is what you get. Half into A is 13.49 by 1000. Correct? That's what you might have. Half into 13.49 by 1000. That is acceleration. Into T square. T over 10, 100 over. So 100 is 10 other cancel. 1 by 10. So 13.49 by 10 is 13.49 by 10 is 1.349. You have a 2 in the denominator. So 1.349 by 2 is going to be 0.6745. 0.6745. That's going to be the answer. That is the distance covered by the object. Why am I doing it? This time I want to follow it. But retake us to play. The breaks are. You said one of it. It's getting rusted. Do the next one. Circular track is bent at an angle of 15 degrees, right? If the coefficient of friction between the wheels and the race car is 0.2, what is the optimum speed? So what is the optimum speed? Root of so what is the answer? RG tan theta under root. So R is how much? 300 in G, you can take it as 10. See, if this question had been an MCQ, don't take it as 10. Because your options will vary. Since it's a subjective, you can take it as 10 here. What is the value of tan 15? So tan 15 is tan 45 minus 30. So tan 5 by 4 minus theta will be 1 minus tan theta by 1 plus tan theta. 1 minus 1 by root 3 by 1 plus 1 by root 3, you will get root 3 minus 1 by root 3 plus 1 is root 3 minus 1 the whole square. 3 plus 1 minus 2 root 3 divided by 2. So 2 minus root 3 will be tan 15. Pretty clear. Root 3 minus 1 by root 3 plus 1. Raise place. So root 3 minus 1 by root 3 plus 1 whatever. Root 3 minus mind pen root in mind. Root 3 minus 1 by root 3 plus 1. Root 3 minus 1 by root 3 plus 1. So root 3 minus 1 the whole square. Numerator root 3 minus 1 the whole square. 3 plus 1 minus 2 root 3. Denominator a plus b into a minus b. So 3 minus 1, 2 வருது 4 minus 2 root 3 is the numerator. So 4 minus 2 root 3 by 2. 2 minus root 3 is what is tan? 2 is how much? 2 is 2 only. 3 you can take as 1.73. 2 minus 1.73 is 3.37. 0.27. So 0.27 will be the value of tan 15. So this you can't directly calculate it, not an issue. This I can understand. I'm not going to ask you to calculate square root and find it. So if there is a way, do it 3 into actually panla. Because 0.27 is a multiple of 3. So 300 into 0.27, 81 hours. So square root of 81 hours. 9 into square root of 10. That's the overthink. 9 into square root of 10. Square root of 10 is 3.3. So 9 into 3.3 calculated, that will be the required answer. That's 197. Right, 9 3 is 27. I can be somewhere close to 27 plus. So 29.7 will be the answer. Those many meters per second will be the optimum speed required for your data. Unless you have a digital speedometer, you can't tell that. No, pointer. Let's see how the car meter looks like. So maximum permissible speed to avoid slipping. Formula with the software. That's the given 0.2. So 0.2 plus tan theta is how much? 0.27 divided by 1 minus 0.2 is 0.27. So numerator 0.2 plus 0.27. 0.47 the numerator, remember that. Divided by 1 minus 2 into 0.27. 0.54. 1 minus 0.54. 100 minus 54 out of 46 are so 0.46. 0.47 by 0.46 approximate one. Square root of R square root of R is 300, 300 into 10 root 3000. So 3000 30 into 100 so 10 root 30. 30 at 50. 5 into 10 root 30 and the root 30 calculate we need to multiply. So 10 root 30 will be the answer. So square root fortunately we escaped in this problem. Square root of RG is square root of 3000 is basic square root at the Arthur sir. For example, I want to find the square root of 132. More number. So first thing you have to see is the number of digits. Whether the number of digits are odd or even. If it is odd, look at the first number. Look at the first digit. So when will you obtain that one? When will you obtain one? 1 multiplied with 1 is 1. See, for example, wherever numbers are 3 digits. 562. Okay. So look at the first digit. It is 4, right? Sorry, 5. So what is the nearest square that is there? 4. So how do you obtain that 4? 2 into 2. You can say 4 into 1 also. You should not do that. When you are finding the square root, the same number should be written. So 2 into 2 is going to give you 4. Like long division, subtract 5 minus 4. 1. So in long division, you bring only one value down, but in this one, bring 2 values down. Okay, 162. Okay. Now what you need to do is add this values. 2 plus 2. 4. So beside that 4, you need to put a number so that you put the same number on top. Right? So that the multiple of these two numbers should be closer to 162 or exactly 162. For example, if there is 4 is there, if I put 1 here, I should put 1 here. So 41 into 1, 41. 2 quota, 2 quota, 84. 3 quota, 3 quota. 120, 129. 44 quota. So 44, 176 4. So then 43 into 3. So 3, 3. 129. How much is it going to be? 3, 33. So 0.00. Bring 2 zeros down. So in the 43, we add 46. Besides this, you need to put a number. The same number should come there. What will be the answer? Look at the last digit. No, here you are somewhere around 33. 33 na 4 la baat 4 la 33 na where will it be crucial? Somewhere around 8 or 9. 9 or 9 na 36 also. So 8 quota 32 also. So 32 la since the number is fixed, should either be 7 or 8. Either or 7 varda. So that alone you need to try and 467 into 7, 468 into 8. So if you do 1, you will get the answer for that. 467 into 7, 49, 4, 42, 6, 4, 42, 4, 6, 28, 32, 3269. So 3269 to 3300 is it greater than 467? Or you complicate? Make it as 468 2 and C, whichever is small, take the term. When you keep proceeding. So answer will be 23.8. For example, the 182 rupiah. I told you 182 is 13.49. 2 and C. How will you do? 3, 6 were how to do it? Yeah. 3269. Yeah, right. So you 1 quota, you 1. That 0. So what will you bring down? 89. So 1 plus 1, 2. Oh, sorry, 82. So 1 plus 1, 2. You need to put a number beside that. What will you put? 1 value, 2 value, 3. 23, 3 is 69. So 69, what is going to be the answer? 13 was the 13.00. Bring these two values down. 13.00. 23 plus 3, 26. So last digit is 13. So it should be somewhere around 4 or 5. That's coming up with 4 or 5, right? Because here I'm getting 1300. So if I put 4 here, what will I get? 4. So is it greater than, so the difference is it greater than 264? Sorry, less than 264? Yes, yes. What will I argue? What concept are you using there? A is equal to PQ plus R, where R is greater than or equal to 0, that's the number with which you are dividing. So now you can do it. This is with respect to 3 digit. So there might be a scenario where you have a 4-digit number. Without possibility. 205. So when you have a 4-digit number, you should not look at the first digit, you should look at the first 2 digits. So what is the nearest square to 20? 16, 4, 4, sir, 16 number, 4 1. Other same logic, 452, 4 plus 4, 8. So in the 45, I'm assuming somewhere number should be 4 or 5. So 85 into 524, what will you get? I think that will work. And at 25 to 425 is what you will get. So 425 na 6 kuda polam. 6 for 6 1 8 6 are 48 1. So 5 to 5. Eduma. What was it? 4 25 dana. 52 minus 25 7. So 27 na that is 0 2700 85 plus 5 90 the number inside there. 2700 9 3s are 27. So 9 3 put up here direct. I need to put only 2. Yes, 3 put up here. Because 900 into 3 is exactly 2700. But if 3 were another, it should get reduced to 52. So is the logic. So 4. How much is it? 18 not 4. Then again, what will you do? 902 plus 2, 904. Other bucket row number, same number should come there. So that's why we stop and do this. Clear? Right. So next time you can do it faster, no? Right. Aircraft executes a horizontal loop of radius 720 kilometers per hour. How do you convert kilometers per hour to meters per second? 5 by 80, 720 to 5 by 80 now. Okay. 18 force is 72, 40, 85. 200 meters per second, right? So angle is given, theta is equal to 50 degrees. What is the radius of the loop? What formula will you apply? What is happening in the air? You have to use the occupant so far we can. Here, of gravity is there. Yes. So velocity is 200 is equal to root of r is how much? The question is, so r is what we need to find out. R into G is 10 into tan 15 again 0.27. So 40,000 is equal to R into 2.7 divide both the answer. So 4 lakh divided by 2. The radius should be in terms of meter. So instead of meter, if you want, you can report kilometer. Okay, next. Obtain an expression for centripetal acceleration. Will you be able to do it? So V square by R. I told you, right? I gave you two derivations for this. What are the two methods I got? One is with vector and differentiation. The second is similarities of triangle. We need to use only similarities for both. I mean, school exam. A constant force acting on an object of mass 3 kg changes its speed from 2 to 3.5 in 25 seconds. The direction of motion of the body remains unchanged for the magnitude of force and direction of the force. What is given? Mass is 3 kg. U is meter per second. V is 3.5 meter per second. Time is 25 seconds. The direction of motion remains unchanged. It's moving in a linear path. And there is a constant force. So constant force means acceleration is constant. So how you find A? So A is equal to V minus U divided by T. So 1.5 divided by time is how much? 25. So A divided by 2. Okay. How much will you get? So 25 into 6 is how much? 150. Answer in 1.5 by 25 will give you 0.06. Here, the acceleration is 0.06 meter per second square. So what is going to be the force? Mass energy 3 into 0.06, 0.18. So force is 0.18 and direction would be 1.18. So direction of forces, the direction of motion of object. Because here you have no specific direction mentioned. So this is also a theoretical concept. This I've explained. Banking of road means a slight elevation which is taking place at the corners of the road. 17. Two bodies of mass 10 kg and 20 kg respectively kept on a smooth on a horizontal surface. First point to be noted: smooth horizontal surfaces are tied at the ends of a right extension. The horizontal force of 6 kgf is called as kilogram force. Okay. Is applied to A and B along the direction of string. Okay. What is the tension of the string in each case? How much is the tension? So F minus T is equal to MA. T is equal to, sorry, M1A. T will be equal to M2A. Cancel both. F will be equal to M1 plus M2 into A. Force is given 60 is equal to M1 plus M2 is going to be 30 into A. Acceleration will be 2 units. So T is equal to M2 into A. Multiply that with the cash. So 20 into 40. You need to multiply it because it's kilogram force. I look it as Newton, for instance. So into 10 will be equal to this value. So 20 meter per second square. That's why I didn't write the units. Okay, 20 meter per second square. Then what will be the value of tension? F2 into A, F2. 20 into 20, 400. The tension will be equal to 400. Here. Yeah, actually, they asked two questions here. One is when the force was applied on block A, what would have been the tension? This would have been the tension. If the same force was applied on block B and you tried to pull it, then what would have been the tension? Do it fast. 1 minute time. If the same force F instead of being applied on A had been applied on B, what will be the answer? Acceleration is, you need not actually do it. Acceleration is still the same. When two objects are tied with the help of a string, acceleration is always force applied divided by the sum of all the masses. So acceleration is still 20. But this 20 is getting applied on which mass this time? 10. So 20 into 10. That's the answer. Not 2x. 200 Newton is the answer. So if this force was applied on M1, then the tension in the string would have been 400 Newton. The same force was applied on M2, the force would have been 200 Newton. Okay. Work energy power I thought at this level. Right. As I mentioned, tomorrow without wasting time, you guys are sitting and preparing. Is it clear? You understood how you are supposed to prepare, right? You understood how you are supposed to write in the exam. 1.5 hour, now 1.5 hour, get to prepare. 1 hour you should finish. Otherwise, you have to practice and only then your hand will go fast. And concentrate. Tension on applying your power. Somebody is taking additional, you don't get tense. You concentrate on your head. Clear? So we wind up.